checking your assignment, and there is a few things I'd like to discuss. See, the first question was absolutely right. Second was right. In here, when the area is given, you should write plus minus only here also. All right, you wrote it here, but start with this. All right.
Okay, sir.
And in the later question also.
Sir, but we have to keep plus minus after opening the mod, right?
Determinant. No. See, this is not the modulus function. In the modulus function, you have to write the plus minus after opening the modulus function. But this is determinant. All right, Krishna?
Okay, sir.
So you have to assume the area beforehand. Here also, write plus minus 35 and write the line also. The area can be positive or negative value, but we have to take the positive. That is why we have to write plus minus something like that. All right.
Okay, sir.
Yeah, never confuse determinant with modulus function.
Okay, sir.
All right. Let's wait few minutes for the students to come. All right. Hello, Kulsum.
Hello, sir. I'm sorry I was late. I had the class before this.
Kulsum, your voice is very low.
I'm sorry, sir. I was late. I had the class before this.
All right, no worries. Kulsum, I was checking your assignment and I found a few things to discuss here. See, you wrote a cube equals to a square times a. That is absolutely right. But how did you find a square? Right? That also you have to show the calculation. All right.
Okay.
And yes, everyone please mention your names also on the assignment. All right. Here, write your names also. Yeah, that is all. I think everything else was fine. All right. So Kulsum, you have to show all the calculations that you do in a question.
Okay, sir.
All right. Then let's start today's class. Everyone remembers what we did in the last class?
Yes, sir.
All right. Then tell me what is identity relation?
Sir, a relation in which it is like of order a comma a and comma b comma b.
All right. there is one specific thing that you have to mention, that there should be only these elements, a comma a, b comma b, c comma c, and so on. No other element can be there, right?
Yes, sir.
All right, Kulsum, what is? Give me a second. All right, what is reflexive relation?
Relation with A comma A.
Right. So, anything more you would like to tell on this?
Let me.
See, first thing is there must be a comma a, b comma b, and c comma c for all the elements, right? For all the elements. And secondly, it doesn't matter if there is a comma c or b comma a or any other element in that relation, right?
Yes, sir.
All right, then. So these are reflexive relation and identity relation. I hope no one has any issues with that. Give me a minute. Alia, are you joining this batch? Give me a minute. All right, everyone. All right. So next is symmetric relation. Hello, Shekhani. Am I audible?
Yes, sir.
All right, Shekhani. Any doubts from the last class?
No, sir.
No. All right. I've just started the class. All right. Today we're going to learn about symmetric relation. So what is symmetric relation? First understand, and I'll give you enough time to write. A relation R on a set A is said to be symmetric if A comma B belongs to R, implies that B comma A also belongs to R. All right. What does this mean? Shikani, what was happening in reflexive relation? Can you explain?
Sir, I don't remember. 1 minute. Let me check my book then out, sir.
All right. Let me remind you then. All right. See, if you had A comma B comma C, then in a relation, for that to be reflexive, you should have B comma B, A comma A, and C comma C, right? Any other element, there is no issue. Then this
Yes.
would be reflexive. What is symmetric saying? Symmetric is saying if you have A comma B in this relation, all right, what this means is if I write A comma C here, one element, if you have A comma B, then you should have B comma A as well. That means C comma A must be there also. Is this clear, everyone?
Yes, sir.
Yes, sir.
All right, listen to this again. If you have A comma B, then you must have B comma A as well. All right, if you don't have A comma B, then no issue. All right, if you have A comma A, then you must have A comma A also. Is it clear?
Yes, sir.
Yes, sir.
All right, Kulshum, Ronaldo.
Yes, sir.
Yes, sir.
All right, then write it down. This is called symmetric relation. All right, mirror image.
Done, sir.
All right. One simple note to add: the identity relation and universal relation on a non-void set is always symmetric, right? How? If I write one set A, 1, 2, 3, then what would be the identity relation? Anyone can tell me the answer? On set A, if I use identity relation, what should I write? The elements.
So 1, 1, 2, 2, 3, 3.
Right? So this would be the identity relation. Is it a symmetric relation or not?
Yes.
No, sir.
All right. Who said no? Krishna, did you say no?
Okay. Yes, sir. I get it.
Right. Kulsum and Ronaldo said yes, I guess, right? All right. So Krishna, again, is this a symmetric relation?
Yes, it is because both the
Right.
elements are same.
Right. So 1, 1 is there and 1, 1 is there. So we have no issue. Same with 2, 2 and 3, 3. Right. And Shekhani, this is clear? Shekhani, this is clear?
Yes, sir.
All right. Now what would be the universal relation? Let's call that U. That would be 1, 1, 2, 1, 3, 2, 1, 2, 2, 2, 3, 3, 1, 3, 2, and 3, 3. Right? This is the universal relation. Is this a symmetric relation or not? Write the answers on the chat. All right, don't say the answer on the speaker. Please send me on chat if U is a symmetric relation or not. All right, I've got 2 answers. All right, Shekhani, what about you? Is this a symmetric relation or not?
Yes, sir. This is a symmetric relation.
Right, absolutely right. So everyone is correct. This is a symmetric relation. That is why this note that the identity relation and universal relation on a non-void set is always symmetric. All right, this is clear to everyone.
Yes. Yes, sir.
All right. universal relation, this universal relation is reflexive or not?
Yes, it is reflexive.
Yes, it is reflective, right? Because 1, 2, and 3, 1, 1 is there, 2, 2 is there, and 3, 3 is there. And if I ask you, is this a identity relation or not?
No. No, sir.
No. So everyone is clear about this. Write it down, this statement in these examples. All right, everyone who noted that down, write down this question and send the answer in the chat. Which of these relations are symmetric and which are not?
Sir, R1 is not symmetric.
All right, you can send the answer in the chat. All right, I've got one answer. Ronaldo has sent me the answer. All right, Shekhani, send the answer in the chat. All right, Kulsum, I've not received your answer yet.
Sir, can you please explain the symmetric again?
All right, see, you don't have to focus at anything else, just look at this. If you have got 1, 2, then you must have 2, 1 also. All right, it doesn't matter what else you have in here. If you have 1, 2, then you must have 2, 1. If you have 2, 3, then you must have 3, 2. All right, the pair must be always there. Is
Okay,
it clear,
sir, got
Kulsum? All right, so you have to check for each individual element if the symmetric pair is there or not. All right, Krishna, you have not answered the chat yet.
Yes, I was writing the question.
All right. All right. Let's check. Kulsum, R1 is symmetric or not?
No,
No. Why not?
B comma A is not there.
B comma A is not there. So everyone who said are symmetric, why so?
Because for AC, A comma C there is C comma A, and for
C comma C.
B comma C there is C comma B.
Right. But for A comma C, you don't have, sorry, for A comma B, you don't have B comma A.
Yes, sir.
Yes, sir.
So this will not be a symmetric relation. I told you for all the elements, for each element, the opposite pair must be there. Always. All right.
Yes,
Yes,
sir.
sir.
Shekhani, why did you change your answer? You were right for the first time, but you then change the answer.
Sir, in R1, AA is there, AB is there, and BA is also there. Okay, wait,
no,
I know. BA is not
BA,
there.
right. BA is not there, so this will
Yes.
not be a symmetric relation. What about R2, Shekhani?
R2 is symmetric, AB is there, BA is there, AC is there, and CA is there. So it's symmetric.
Absolutely right. So this is symmetric. And R3?
R3, AB is there, but BA is not there, BC is there, and CA is there. So it's not
Right,
symmetric.
right. So you don't even have to check for these, right? AB is there, but BA is not there, so this will not be symmetric. All right. You never have to check for the other elements if you get one bad element.
So for B element, it's not there, right? BC is not there. Second one.
In R3, are you saying, or
Second
R2?
one, sir.
In R2, which is not there, see, A comma B is there, so BA comma A must be there. Yes, the pair is here. A comma C is there and C comma A is there, so this is a pair. All right.
So, but that B comma C and C comma B also missing, right?
No, but that doesn't matter, right? I told you, you don't have to look at anything else. Just look at the pairs. If 1 comma 2 is there, then 2 comma 1 must be there. All right.
Okay, sir.
All right then. Everyone is clear about this?
Yes, sir.
Yes, sir.
All right. Let's try another question. Check that the relation on the set A equals to 1 comma 2 comma 3 given by r equals to 1 comma 1 2 comma 2 3 comma 3 1 comma 2 2 comma 3 is symmetric or not. Send the answers in the chat. All right.
So, what is the fourth ordered pair?
1 comma 2. Shikhani, I don't have your answer.
Yes, sir. Answer me.
Is it a symmetric or not? Shikhani, is this a symmetric relation or not?
Sir, it's not, sir.
It's not. So everyone is clear about this because we don't have 2,1, 3,2, right? So this is not symmetric. No doubts there.
Sir, I
Alright.
have a doubt in the identity matrix, sir. How is it symmetric, sir? We don't have another pair which is similar to it, right?
No, see. Suppose there is a set A, 1, 2. So the identity relation would be 1, 1 and 2, 2, right?
Yes, sir.
So you are saying, sir, I don't have another pair. All right. Do you remember in sets, if I write set A, 1, 2, 3, and 3, is this a valid set?
No, sir.
No. Why? Because we have 2 3s, right? So in sets, you cannot repeat the elements. So if you write 1, 1 here, it doesn't matter. You can write any times of 1, 1, but the resultant set would be this only, right, Krishna?
Yes, sir.
So is it clear now?
Yes, sir. Got it.
So 1, 1 is there and 1, 1 is there. So this is a symmetric relation. Everyone clear about this?
Yes, sir.
All right. Next question. Check that the relation are on the set A equals to 1, 2, 3 given by, and this you have to tell me if this is symmetric, identity, or reflexive. This is 1, 2 and 2, 1 is symmetric, reflexive, or identity. All right, send the answers in the chat.
Sir, is my answer correct?
Right, Shikani, your answer is absolutely right. You are saying it is reflexive. How is it reflexive?
Sir, it is 1 to 1 to 1.
Right, but what is reflexive relation?
Um,
See, in reflexive relation, these elements 1, 2, and 3 must be related to themselves. That means 1, 1 must be there, 2, 2 must be there, 3, 3 must be there. Just look at this. Look at all the elements and look at these elements. If anyone is missing, then this is not reflexive.
So, sir, my answer is wrong here.
Right, this is not reflexive,
Okay.
or not identity, but this is symmetric.
Symmetric.
All right. So I think
It's
everyone
missing
is
the third element, sir. So it's still symmetric.
yes. It doesn't matter if it is missing any element. If 1, 2 is there and 2, 1 is there, then this is symmetric. All right.
Sir, can you remind us what is identity relation also?
Identity. All right. See, identity and reflexive are almost similar. In identity, you cannot have these elements at all. You can only have this, a set of these 1, 1, 2, 2, 3, 3 is identity. But if you write other elements 1, 2 and 2, 3 and so on, this is not identity. All right. Clear, Shikani?
Sir, in identity
Yes,
and
sir.
reflexive, if one of the ordered pair is missing also, is it okay?
No, 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 no. You cannot miss any elements in identity or reflexive. All right.
So, identity is part of reflexive.
Yes, I gave you a note in the last class about that also, right? All the
Yes.
identity relations are reflexive relations, but not all the reflex. Do you remember that movie? I think it was Hum Shakals. Anyone watched that movie? Anyone knows about that movie?
Sir, what is the story?
I like that was a very like bad movie, but where everyone had a double role, right? Double role, you know, one person
Yes.
playing two roles.
Yes.
So suppose there is a movie in which we have three characters, right? One hero, heroine, and a villain. All right, and that movie name is Hum Shakals. In Hum Shakals, if hero has double role, hero and hero, heroine has double role, heroine, heroine, and villain, villain, then this is an identity relation. All right, because we had three characters, all three played double roles, so this is identity. If you miss any of them, then this is not identity. All right, Hum Shakal will be a flop. All right, because two heroes must fight two villains. This is clear.
Yes, sir.
And in reflexive, you can have other roles also. Like suppose in this later story, you got to know that hero and a villain were brothers. So this can be reflexive also. They had two roles and there is a other relation also. So this is reflexive. Is this clear? Everyone?
Yes, sir.
So reflexive can accommodate different roles, but identity cannot. It can only sustain double roles of all the characters present in the movie. This is clear now, Shikani? Shikani, this is clear.
Yes, sir. Sir.
And this specific example was for you only. All right, I think you are forgetting about identity and reflexive.
Yes, sir.
All right, then let's move on. There is another type of relation that is called transitive. All right, and this is also a bit tricky. So listen to this carefully. Don't try to write now. I'll give you enough time to write. What is a transitive relation? A relation R on a set A.
Sir, I think I know this one.
You know this one, all right? Tell
Yeah.
me.
AB, B, AB, BC, and AC. Something like
Absolutely
that.
right. Yes, you defined it very well. That is all about this. So let's write it very clearly, all right? So if a relation R on a set A, it's said to be transitive if A comma B belongs to R and B comma C belongs to R implies that A comma C belongs to R. All right, read it out, everyone. All right, just read it and think about this. What this is saying is, if you have 1 comma 2 in the relation set and 2 comma 3 in the same relation set, then you must have 1 comma 3 also. Is this clear, everyone?
Yes, sir.
Yes.
All right, Kulsum.
Yes, sir.
All right, again I'll explain again. If 1 comma 2 is there and 2 comma 3 is there, then 1 comma 3 must be there. We don't care about anything else. If one pair is ending with 2, another is starting with 2, then we must have a third number 1 comma 3. This is clear now?
Yes, sir.
All right, there is another case with this. If I write a set where 1 comma 1, 2 comma 2, 3 comma 3, and 1 comma suppose 4. All right, 1 comma 4. Now this 1 comma 4 has no element as 4 comma 5, right? This is not here, so we cannot say about this is transitive or not. Then we will write this is transitive. All right, if you don't have this missing pair, then this relation will be transitive. All right.
Sir, can you explain once more?
All right, see, if I write a relation 1 comma 2 and 2 comma 4, then for this to be transitive we must have 1 comma 4.
Yes, sir.
But if I write another relation 1 comma 2 and 1 comma 4, and I ask you if this is transitive, then what would you say?
Sir, there is a
No,
special
sir.
case where it will be transitive. Something like that is there.
Right. This is what I'm saying, Krishna. This is transitive. All right, this is mentioned in NCRT, so we must follow that. All right, why this is transitive? Because there is no one to compare. See, in transitive we must check this 1 comma 2 and 2 comma 4, so we must have 1 comma 4. In here we don't have 2 comma anything or 4 comma anything, so we cannot say anything about transitive, right, Krishna?
Yes, sir.
So this would be transitive. All right,
Okay, sir.
so if the third pair is missing, then only we can say this is not transitive. Otherwise everything is transitive. All right,
Yes, sir.
everyone is clear about this? Kulsum, Ronaldo?
Yes. Sir.
All right, write it down then. Done, everyone?
Done, sir.
All right, let me give you a question. There is a set A 1 comma 2 comma 3. All right, write identity relation. and tell me if that is transitive or not. All right.
1 1 2 2 3 3. It's transitive.
It's transitive. Why is it transitive, Shikhani?
There is nothing to compare with.
Absolutely right. Everyone is clear.
Yes, sir.
All right. Ronaldo, Kulsum.
Yes.
Yes, sir.
All right. Now write the universal relation. Tell me if that is transitive or not.
Sir, what does universal relation on A mean?
Universal means everyone is related to everything. 1, 1, 1, 2, 1, 3, 2, 1, 2, 2, and so on.
So, sir, if that's the case, then it will be transitive. But I want to know, like, if there are other elements which do not come as transitive, will the relation be transitive or not?
All right, let me write the universal relation. Does anyone have the answer on this universal relation?
I think, sir, it will be transitive.
It will be transitive, right? So let's write. This is 1, 1, 2, 1, 2, 1, 3, 2, 1, 2, 2, 2, 3, 3, 1, 3, 2, and 3, 3. All right. So for this to be transitive, let's start with first element. 1, 1 is there and 1, 1 is there. 1, 2 is there. So 2, 1 must be there. Sorry. We are checking about transitive. I forgot. All right. 1, 1 is there. 1, 2 is there. That means 1, 2 must be there. Is this clear, everyone?
Yes, sir.
All right. Now again 1, 1 and 1, 3. So 1, 3 must be there and 1, 3 is there. Is this clear?
Yes.
Yes, sir.
Yes.
All right. Now 1, 2 is there and 2, 1 is there. That means 1, 1 must be there. It is here. This is clear what I am doing, or it's all confusing?
It's clear, sir.
All right. And 1, 2 is there. 2, 2 is there. That means 1, 2 must be there, and it is there. 1, 2 is there. 2, 3 is there. That means 1, 3 must be there. So 1, 3 is here. Now last element 1, 3, 3, 1. So 1, 1 must be there. 1, 3, 3, 2, 1, 2 must be there. 1, 3, 3, 3, 1, 3 must be there. All right. Now you have to do this all the elements 2, 1, 1, 1. So 2, 1 is there. All right. And if you do all this, you will see that this is a transitive relation. All right, everyone.
Yes, sir.
Yes.
Yes, sir.
All right, Shekhani. Now this is clear.
Yes, sir.
All right. So you have to do till this. This is a very lengthy question. If right, just pray to God they don't give any question like this. So you can write the note that identity relation and universal relation on a non-word set is always transitive. All right, write it down. All right, this is your question. You have to tell me if R1, R2, or R3 is transitive or not. Send the answers on the chat. All right, and do this very carefully. As you can see, this can be tricky.
Sir, what is the last relation first ordered pair?
A comma B, B comma C, and C comma A. I'm telling you again, everyone, please solve this very carefully. All right, all the answers are incorrect. So please carefully check if that is transitive or not. All right, you have to check for each element. Absolutely right, Krishna. Now you are right.
Sir, if in a set some of the elements are transitive, that means the set is transitive or not?
No. If either everyone is transitive or not at all. All right, you cannot miss even one single element.
Okay, sir.
Everyone is sending me different answers. Let's see. Shall I solve this, or you guys want to try a few more minutes?
Sir, you solve it, sir.
All right,
Just a minute.
just a minute. All right.
Sir, is my answer right?
Yes, Krishna, your answer was right. And now Ronaldo is right also. So both of you have come to the realization. Kulsum, what happened to you?
I don't understand. Sir.
Don't understand. All right, let's see. Let's dissect the first one. All right. R1. A comma A is there. A comma B is there. So A comma. Let me write it here. A comma A is there, A comma B is there. So A comma B must be there. Yes, it is here. This is clear, everyone?
Yes, sir.
Now A comma A is there and A comma C is there. So A comma C must be there. Yes, it is here. And no other element starts with A. So let's move on to second element. A comma B is there and B comma B is there. So A comma B must be there. Yes, A comma B is there. This is clear, everyone?
Okay, so we take the
Yes.
first and last coordinate.
Right. Always take, see, whenever you take one element, start with the first element, A comma A. Now look at all the elements that start with the second element. All right, make the pairs and take the first and the last. All right, this is the step to solve, but don't remember the step, just understand this thing. If A comma B is there, B comma B is there, then A comma B must be there. All right, A comma B is there, B comma C is there, so A comma C must be there. All right, is this clear, Kulsum?
Yes, sir, it's clear now.
All right, now no element starts with B, so let's move on to the third element, A comma C. So A comma C is there and C comma A is there. So A comma A must be there, but A comma A is there, right? A comma A is there. All right. Now A comma C is there and C comma B is there. So A comma B must be there. A comma B is there. A comma C is there. C comma C is there. So A comma C must be there. This is also right. All right. Now what is remaining? B comma B is there. B comma C is there. So B comma C must be there. That is also clear. Let's start with B comma C and C comma A. B comma A must be there. All right, see. In B comma C and C comma A, B comma A must be there, but B comma A is not there. So this is not transitive. Is this clear, everyone?
Yes, sir.
All right,
Yes, sir.
Kulsum, Chikani.
Yes, sir.
So you have to solve all of this, right? There is no fast forward way. You can check this in your mind also. You don't have to write all of this, but you have to go through all of these calculations. All right, so B comma A is not there, so this is not transitive. If you miss even one single element, then this cannot be transitive. Now for the second one, A comma B is there, B comma A is there, A comma A must be there, but A comma A is not there, so this is also not transitive. This is clear? Everyone, is this clear?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
All right, now the third one. Third one is very easy also. A comma B, B comma C. So A comma C must be there, but no. So this is not even transitive. So no one is transitive here. All right. You can write
Yes,
the
sir.
answer. All right. No doubts, I believe.
No, sir.
All right. You can write the answer. All right. Write this down, how to solve. All right. Note it down the answer that none of them are transitive.
Yes, sir.
Kulsum. All right. Kulsum, this is clear, right?
Yes, sir.
All right. Now last of this is equivalence relation. All right. If a relation R on a set A is reflexive, that is A comma A belongs to R for all A belongs to A. Symmetric, that is A comma B belongs to R implies B comma A belongs to R for all A comma B belongs to A. And transitive, that is A comma B belongs to R and B comma C belong to R implies A comma C belongs to R for all A comma B comma C. Then it is equivalence relation. All right, if a relation is all of these three, reflexive also, symmetric also, transitive also, then we'll call that equivalence relation. This is clear, everyone?
Yes, sir.
Note it down. This is very simple. We have understood about these three. If a relation is all three, then that will be a equivalence relation. Note it down.
Sir, can you explain equivalence relation again?
All right. If there is a relation given to you, all right, and that is all three, that means if you check, that turns out to be reflexive, symmetric, and transitive. All right, then we'll call that relation is a equivalence relation. All right,
That's it?
that's it.
Oh,
Nothing
okay.
else.
Ah,
That is why I said this is very simple. No new conditions for that. All right, note it down.
yes,
Yes,
sir,
sir.
finished.
All right, let's start with the question now. Check the following relation R for reflexivity, symmetricity, and transitivity. A is related to B, if B is divisible by A. All right, the question is clear to everyone. You have to check this relation R is reflexive or symmetric or transitive, and the relation is given by A is related to B if B is divisible by A. All right, where A and B belongs to natural number. All right, send the answers in the should I solve this, everyone, or you guys want to try this first?
Can you solve it?
All right, see, in the examinations the writing also matters, right? So you have to write it very carefully also. Let's start with the answer. Okay, the question is clear, everyone. If B is divided by A or divisible by A, then A comma B will be in the relation set. All right, and this set is from natural numbers. So for reflexivity, all right, we know that for all A belongs to natural number, A is divisible by A. This line is clear, everyone,
Yes, sir.
Yes, sir.
right? You take any number, any natural number that would be divisible by itself. That means A is related to A for all A belongs to natural number. This is clear.
Yes, sir.
This means, this implies that R is a reflexive relation, right? If all the numbers are related themselves, then that is called a reflexive relation, right, everyone?
Yes, sir.
Yes, sir.
All right, this is clear, everyone, the writing style and the concept behind that.
Yes, sir.
All right, now for symmetric. Can anyone tell me if this is a symmetric relation or not?
No, sir.
No. All right, Ronaldo. What does symmetric relation say? If 4 is divisible by 2, then 2 must be divisible by 4, right?
Yes, sir.
Yes.
But that is not the case, right? The question says A or B if B is divisible by A. That means if I write 2 or 4, then 4 is divisible by 2. If this is
Sir,
symmetric, then
sir, your internet went for some time.
is it so, everyone? Was I audible?
Yes, sir. You're audible.
Yes, sir. You're audible.
All right, Shekhani, then please check
Then
your
mine
internet
maybe.
connection.
Yes.
Right. All right. So if 2 is related to 4 and the relation is symmetric, then 4 must be related to 2 also. That means
Yes, sir.
2 must be divisible by 4, but that is not 2. Is this clear, everyone?
Yes, sir.
Yes, sir.
All right, let's do one thing. Write it down first. This step I'll need space. All right, write it down, then I'll explain how to write about symmetry. Kulsum, this is clear till now?
Yes, sir.
All right.
Done, sir.
All right. So if a relation is reflexive or symmetric or transitive, then you have to write all this language to prove that they are reflexive or symmetric. But if you see even one example where this is not symmetric, then you can write just that example and it will be proved. All right, what this means is, how to say this is not symmetric? You can simply write 2 is divisible by 1. This implies that 1 comma 2 belongs to R, and R is the relation, but 1 is not divisible by 2. This implies that 2 comma 1 does not belongs to R. All right, so R is not a symmetric relation. Is this thing clear, everyone?
Yes, sir.
Yes, sir.
Sir.
All right, wholesome.
Yes, sir, it's clear.
But remember this, you cannot prove by example. All right, you cannot give examples and prove that this is a reflexive relation. You have to generalize the solution to prove something is true, but you can prove that this is not symmetric just by giving one example. All right, I told you even one element is missing, then that is not symmetric or transitive or reflexive. So we prove by that. All right, note it down.
Done, sir.
All right, now for transitive. All right, is it transitive or not?
No, sir.
Anyone? No, this is not transitive. All right, anyone says this is a transitive relation? Kulsum, Ronaldo, Shikani?
And no, sir, it's not transitive.
Sorry, Ronaldo, you are not audible.
It's not transitive.
It's not transitive. All right, Kulsum, what about you?
No, sir.
No. All right, why not?
If we take the example before, if 1 is divisible, 2 is divisible by 1, but 1 is not divisible by 2.
Right, but that is symmetric, right? What is
Yeah,
transitive?
but we need
See,
to have
transit,
2 elements. If 2 is divisible by 1 and 1 is divisible by 2, but 2 is, uh, yeah, 2 is divisible by 2, so it is transitive.
right? But see, in transitive, what you have in transitive, you must have A related to B and B related to C. These two must be there already, right? Where you are giving the example, 2 is divisible by 1. So you are telling 1 related to 2 is there, and you are saying 1 is divisible by 2. That means 2 are 1. But this is not there, right? So you cannot take this as example. Am I
I
clear?
didn't understand, sir.
All right, see. Let's write the relation set. All right, few elements there. We will write 1 comma 2, right? 2 comma 4, 3,6, and so on, right? What does transitive say? Transitive says if 1,2 is there, 2,4 is there, then 1,4 must be there. While you were giving the example, 1,2 is there and 2,1 is there. That means 1,1 must be there, right? Also, were you not giving this example 1,2 and 2,1?
Yes.
But you cannot give this example because 2,1 cannot be there in this relation set, right? Because 1 is not divisible by 2,
Yes.
right? So you cannot take this example. Am I clear?
Okay.
All right. So Shikhani, what is your answer here?
Yes, sir.
Is this a transitive property or not? Transitive relation or not?
Sir, it's not.
It's not. All right. Krishna, can you tell me why not?
So because the second condition doesn't agree to
Sir,
into
actually, it is, I guess, transitive because 1, 2, 2, 4, and 1, 4.
Right, but we have to generalize, right? We cannot just take one example. We have to say this for all the natural numbers. All right, Krishna, what were you saying? You cannot take which example?
No, sir, I'm saying the second condition, sir. Like if the first condition is met, but we need the second condition to also be true so that it can be transitive. That is, if one is related to two, but two is not related to one, right? So we cannot take it as transitive.
No, that is the condition for symmetric, right? Transitive doesn't say that.
No, sir,
Transitive says,
I'm saying if, okay,
right? Transitive says if you have A comma B and B comma C. That is not saying that you must have B comma C. It is saying if you have A comma B and B comma C, then you must have A comma C. It is not saying that you must have B comma C also.
yes,
You
sir, but
get my
in this
point?
relation, B comma C is not there. That's why we're not having it, right?
That means it is transitive. I told you if you don't have anything to compare with, then that is transitive.
Okay, sir.
Right? But you have B comma C also because you have 1 comma 2 and 2 comma 4, right? So you have A comma and B comma C.
Yes, sir.
Am I clear? Everyone is clear with this or not?
Yes, sir.
So, sir, it is
Or,
transitive.
right, this is transitive. All right, Kulsum, this is clear.
Yes, sir.
See, why this is transitive? Let me make you understand transitive once again. I think there is still some gaps in the concept. Transitive says if you have A comma B and B comma C, all right, it is saying if you have both. It is not saying that you must have both. It is saying that if you have a scenario where you have both A comma B and B comma C, right? The second element, the first element, both are there in two ordered pairs. All right, then you must have A comma C as well. It is not saying that if you have A comma B, then you must have B comma C. This is fine. This is okay with transitive. If there is only one element A comma B, this is transitive. It is saying that if you have both A comma and B comma C, then you must have A comma C as well. Is this clear?
Yes, sir.
All right, everyone, this is clear.
Yes, sir.
All right, so now look at this. How to write? Let's say A, B, C belong to natural numbers. All right, and A is related to B and B is related to C. Everyone is clear why I wrote this? Because for transitive, we must have these two. All right, now we are saying to prove that suppose we have three elements set A is related to B and B is related to C. Suppose, all right. Here this means that B is divisible A, and here this means C is divisible by B. Is it not?
Yes, sir.
So does this imply that C is divisible by A?
Yes.
Yes, everyone, this is clear?
Yes, sir.
So for
Right.
transitive, we always need 3 elements in a set.
Right, we always need, no, see, A and C can be similar or same also, but to generalize, we have to take 3 different elements, right?
So if we want to give an example for the proof, we have to take 3 elements.
Right.
Okay, so
All right. So this line is clear. If B is divisible by A and C is divisible by B, that means C is divisible by A. Everyone is clear with this thing?
Yes, sir.
All right. That means A is related to C or not?
Yes, sir, it is.
So we can say A comma C is belongs to R.
Yes.
If A comma B belongs to R and B comma C belongs to R, then A comma C also belongs to R. This means R is transitive on N. Is this clear to everyone or not?
yes.
Yes,
All
sir.
right. All right. So think about transitive very carefully. All right. Don't judge a question by its cover. All right. So write it down.
Done, sir.
All right. Let's start another question. Check the following relation. For reflexivity, symmetricity and transitivity. L1 is related to L2 if L1 is perpendicular to L2, where L1 and L2 are straight lines in a plane. This question is clear, everyone?
Yes, sir.
Do you want to solve it by yourself, or should I solve this? Ronaldo, do you want to solve this?
Sir, I'm not sure about this, so I think we should solve it.
All right. Just all right. Don't write down the solution. Just try to solve if it is reflexive, symmetric, or transitive. All right. In your mind only. Think about this. What does reflexive say? That if one straight line is perpendicular to another, and the other must be perpendicular to this line, right? Oh, sorry. What is reflexive says? L1 and L1 must be related, right? Reflexive says every line must be related to itself. Is this true or not?
Yes, sir.
So is it true for this question?
No.
No, because they can be related only if they are perpendicular, and one line cannot be perpendicular to itself. Is this clear, Ronaldo?
Yes, sir.
So this is not reflexive. And so about symmetric, if one line is perpendicular to another, then this must be perpendicular to this. So this is symmetric or not?
Yes, sir, it is.
Yes, sir.
It is. Now think about transitive by yourself and tell me if these are reflexive, symmetric, or transitive. I'll tell you how to write. All right, don't worry. I'll write down the solution properly. But you think about if this is transitive or not. All right, Krishna has sent me the answer. Kulsum, is it transitive or not?
It's not
Kulsum,
transitive.
it's not transitive. All right, Ronaldo,
Sir, it's not transitive.
not transitive. All right, Shikani, Shikani is not answering. Let's see. For reflexive, you can simply write
So like
Better.
if L1 is perpendicular to L2 and L2 is perpendicular to a third element L3, but L1 is not perpendicular to L3. It can be parallel but not perpendicular. So it's not
Absolutely
transitive, right?
right. You have to write that only whatever you said. If you write that much, then you will get full marks. All right. So let's start the solution. Reflexive. A line cannot be perpendicular to itself. So R is not reflexive. Right? We cannot write any more than this. For symmetric, if L1 is related to L2, this implies that L1 is perpendicular to L2. This implies that L2 is perpendicular to L1. This implies that L2 is related to L1 also. So L1 comma L2 belongs to R implies that L2 comma L1 belongs to R. So R is symmetric. This is clear, everyone?
Yes, sir.
Yes, sir.
All right. Note it down. Then I'll write what to write in transitive.
Done, sir.
So how to write for transitive? Right, we can say let L be all this set of all the straight lines in a plane. All right, and L1, L2, and L3 belongs to L. Now, whatever Kusum said, we can write if L1 is related to L2 and L2 is related to L3. You can even draw a diagram. This L1, L2, and L3. All right. If L1 is related to L2 and L2 is related to L3, this implies that L1 is perpendicular to L2 and L2 is perpendicular to L3. This implies that L1 cannot be perpendicular to L3. This implies that L1 is not related to L3. Is this clear, everyone?
Yes, sir.
So we can say L1 comma L2 belongs to R and L2 comma L3 belongs to R, but L1 comma L3 does not belong to R. So R is not transitive. All right, you have to write all this because there is step marking. All right, and the only issue you will face is the written steps. So write it down carefully.
Done, sir.
All right, let's try another question. Let the relation R on this set are real numbers be defined as A comma B belongs to R. Let's call this R1. All right, belongs to R1 such that 1 plus AB should be greater than 0 for all A comma B belongs to R. Show that R1 is reflexive and symmetric, but not transitive. All right. Do you guys want to try solving this by your own, writing the solution, or
Yes, sir. Let us our own.
all right? I'll give you 2-3 minutes for this.
Sir, can you scroll up?
Right, right.
Sir, can you do it, please?
All right. All right. So to prove this relation is reflexive, we have to prove that all the elements will be related to themselves. So for reflexive, let A belongs to R. All right. A is any element that belongs to the set R. If A related to A, or let's write, so 1 plus A times A should be greater than equals to greater than 0. Is this clear, everyone? We are
Yes, sir.
checking if 1 plus A times A is greater than 0. So this is 1 plus A square is greater than 0. Now if A is a real number, so A can be either positive, negative, or 0, right?
Yes, sir.
And A square is always positive or 0.
Yes.
This is clear. All right. Ronaldo, Kulsum.
Yes, sir.
All right. That
Yes.
means if A square is either positive or 0, that means 1 plus A square is always positive. So we can say A is related to A for all A belongs to R. So R1 is reflexive. This is clear, everyone?
Yes, sir.
Yes.
Now for symmetric, let A comma B belong to R and A is related to B. This implies that 1 plus A times B is greater than 0, right? Symmetric says if A is related to B, then B must be related to A. So we are seeing that if A is related to B, that means 1 plus A dot B must be greater than 0. We know that multiplication is commutative. So 1 plus B dot A, I can write. Any problems, anyone?
No, sir.
No, sir.
So we can say B is related to A. This means if A comma B belongs to R, this implies B comma A also belongs to R. So R1, this is all R1. So R1 is symmetric. Everyone is clear about this?
Yes, sir.
Note it down. Then we'll see transitive.
Sir, how do we show if it's transitive or not?
Right? They have asked you to show that this is not transitive, right? They have mentioned to prove that this is not transitive. So can anyone give me an example how to prove that this is not transitive? I told you if you have to prove that not symmetric, not reflexive, or not transitive, then you just have to give one simple example. All right. You can take any example. Anyone has any ideas?
Sir, we will take a number example.
Right. You can take any number.
So -3, 2.
-3, 2
and 2, 3.
2, 3. All right, let's see first if this is true. So 1 plus -3, 2 should be greater than 0, but this is not true. So you cannot take this element.
So we can take, sir, 2, 3 and then 3, 4.
3, 4. All right. So 2, 3, 1 plus 6 is greater than 0, right? And 1 plus 12 is greater than 0. But 2, 4 is also there. And 2, 4 is also right, right? 1 plus 2 times 4 is greater than 0. This is true. So this does not prove this is transitive. This proves this is transitive.
So -3, -2, I think.
Wait. -3, -2, and
-2 and -1.
let's see. So 1, this is plus 6, right? This is greater than 0. And this is 1 plus 2 is greater than 0. So in transitive, we will have -3, -1. But this is also greater than 0.
Sir, I tried with 1/2 and -1.
Wait. Tell me again.
1/2 and -1.
1, 1/2. And the other element is
Minus 1/2 and -1.
-1. All right, let's see. So 1 plus 1 times 1/2 is greater than 0. That is true. 1 plus half times -1. This is also greater than 0. Absolutely right. And the transitive property gives us 1, -1. So 1 plus -1 is not greater than 0. Absolutely right. So this is the example you can take. Everyone is clear about this,
Yes, sir.
right? So very good, Kulsum.
Sir, is there
Transitive.
any easy way to generate these examples?
No, you have to observe. There is no easy way to think. All right, but you could have observed very easily that. See, they are asking you to take two examples such that this must be greater than 0, this must be greater than 0, but the other pair must not be greater than 0. That means one of them must be negative, right?
Yes.
This you can think. Now you can think that if this is negative and this is positive, that means that number must be less than 1.
Yes.
So you can think like that. All right, there is no other way or any formula to calculate, take examples. You have to observe and think. All right, Krishna.
Yes, sir.
All right, so how to write transitive? You can take two example that 1 comma half belongs to R1 and half comma -1 belongs to R1, but 1 comma -1 does not belongs to R1. So this is R1 is not transitive. All right. Sorry. This is clear.
Yes, sir.
Everyone, Ronaldo.
Yes, sir.
All right, so note it down. Done, everyone?
Yes, sir.
All right. So everyone is clear about symmetric relation and transitive relation?
Yes, sir.
Yes.
Yes, sir.
All right, Shekani, what is equivalence relation?
If the relation is reflexive, transitive, and symmetric, it is known as equivalence.
Absolutely right. All right. So anyone has any doubt in today's class?